Hey everybody, and welcome to this episode of Programming and Algorithms. In this episode we're going to look at the idea of iteration, or repeating a task over and over again. The most common way iteration is implemented is in the while loop. So in the same way with the if statement we did a while ago, the if statement is a common way of implementing selection. For iteration, the most common way is the while loop. Because sometimes we want to repeat a task many times, so we need to tell the computer program do this again, and keep doing it until something happens. So what have we got? Let's think about searching a phone book and trying to find the right entry in a phone book. So if we started using an if statement, how that would look is get the first entry. If that's the correct entry, then write it down. If it's not, then get the next entry. If that's the correct entry, then write it down, else get the next entry. If that's the next entry, write it down. If it's not, so let's say for a phone book with, 10,000 lines in it, we're going to have 10,000 if statements embedded in each other. If it's this one, you found it, else look for the next one. If it's that one, you found it, else look for the next one, and keep on going. You couldn't really write that as code, no more than if you said to somebody, you've got 400 choices to pick from. We couldn't have an if statement for each of the 400 choices. It just wouldn't be reasonable. So instead we've got the structure called the while loop, and we rewrite that statement as the while loop as follows. What we say is we get the first entry. We call that entry, we give it a variable name of n. While n is not the required entry, do get the next entry, call that n. It gets to end while and then it goes back to the word while again. If the next entry, which is n now, is not the required entry, then we will do get the next entry, call this entry n, we'll check in the while loop condition, is that the right one? If it is, we'll exit the while loop. If it isn't, we'll keep on doing, getting the next entry and calling it n. So as we can see, the structure of the while loop is while some condition, do a sequence of statements, and end the loop with end while. As soon as the code, the pseudocode in this case, gets the word end while, it jumps back immediately, goes back to the word while. It checks the condition again to see if the condition is true or false. If the condition is still true, it'll execute what's in the body of the while loop after the do bit. When it gets to end while again, it'll jump back to the while. If at any stage the condition on the while loop is false, then it exits the while loop and doesn't go in and do anything and finishes and continues on the program after the word while. So if we were to make this a pseudocode program, we just throw the name program on top of this, and it's called search for entry, colon, and we end it with end full stop. That's the only difference there. And our general form is while some condition, do a sequence of statements, end while, and keep on doing that while the condition is true, and keep going back from end while up to while, keep on looping back and back and back until that condition is false. And as soon as the condition is false, jump out of the while loop and execute the statement that is right after the word end while. So let's say we want to print out the numbers 1 to 5. The easy way to do this would be print 1, print 2, print 3, print 4, print 5. That would work as an approach to doing it. If we want to print out the numbers 1 to 5,000, we'd have to type out print 1, print 2, print 3, print 4, all the way to 5,000. So a loop allows us to do this in an easier way. If we want to print out the numbers, we have our program, it's called print 1 to 5. We say that we declare a variable, call it a, and it gets the value 1. And we keep on looping around while that variable a is not equal to 6. We do print out the value of a, and then we add 1 onto a, so a gets the value a plus 1, and then we go end while. So what happens here? A starts off as being 1, then we check is 1 equal to 6? Is 1 not equal to 6? 1 is not equal to 6, so we go into the do part, we print out a, which is 1, we add 1 to a, it's 2. End while, we go back up to the while. 2 is not equal to 6, that's true, so we go into the while body again, we print out the number 2, then we add 1 onto a, then it's 3. 3 is not equal to 6, so we print out 3, then we add 1 and it's 4. 4 is not equal to 6, so we print out 4. We add on 1 and it's 5. We go back up again. 5 is not equal to 6, so we print out 5. Then we add 1 and it's 6. But because 6 is equal to 6, that condition is no longer true because 6 is equal to 6, 6 is not equal to 6, therefore we fall out of the int while and finish the program. So we print out the numbers 1, 2, 3, 4, 5, and then we've got the entire. So if we change not equal to 6 to not equal to 5001, then we print out the numbers 1 to 5000. If we change the number to 1,000,001, we print out the numbers 1 to 1,000,000. When it gets to 1,000,001, it falls out of the loop, and then it won't print out 1,000,001. So that's the basis of the while loop. If we want to represent that graphically as a flowchart, we'd say start, and we'd say A gets the value 1, then we go down, go straight down, and we check if A is equal to 6, which is not. Because it's a no, we take the right branch, we print out the value of A, then we add 1 onto A, and then we go back and check that condition again. We keep on going around that loop while if A is equal to 6 is no, and then at some point A will be equal to 6, which is yes, and then we end. So that's the standard format of the while loop as a flowchart. It's the same kind of condition as an if statement, but all the statements are then to the right of the condition. Let's say we want to add the numbers 1 to 5 up and just print out the result using a loop. How we do it is as follows. We'd say print the sum of 1 to 5 would be our program name. Then we'd have 2 variables this time. We'd have A as before, which gets the value 1, 2, 3, 4, and 5. And we've got another variable called total. Sometimes this variable type is called an accumulator because it accumulates the values as they go up. And the only difference between this and the previous program is instead of saying print A, we say that total gets the value of total plus A. So if total starts off as 0, then we add A onto total. A is 1, so that means total is 1 and A is 1. We add 1 onto A and A is 2. Now we say total gets the value of total plus A. Total is 1 and A is 2 this time, so the total is now 3. A now becomes 2, so then we add, A becomes 3, sorry. Then we add total, it's 3 plus 2, which is 5. Then A becomes 4, 5 plus 4 is 9. Then A becomes 5 plus 4 is 9, so then that's the total of 1 plus 2 plus 3 plus 4 plus 5. So the only difference between this and the previous program is instead of printing out A, we add A to a total each time, and then when we finish the end while statement, when A becomes 6, A not equal to 6 is no longer true, so it goes to the statement after the end while, which is print total, and it'll print out your total of 1 plus 2 plus 3 plus 4 plus 5. Let's say we want to, and this is an interesting one, and we'll take this a bit slowly. We want to calculate the factorial of any number. So I don't know if you guys remember from maths, sometimes you'd have a number and an exclamation mark after it. So 5 factorial, 5 exclamation mark means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Or 7 factorial, 7 by 6 by 5 by 4 by 3 by 2 by 1. Or any number n is n by n minus 1 by n minus 2 all the way down to 2 by 3. 2 by 2 by 1. So if we have 3 factorial, it's 3 by 2 by 1, which is 6. If we have 4 factorial, it's 4 by 3 by 2 by 1, which is 24, and so on and so forth. So it's definitely a loop kind of situation where we're going to be counting down from 5 to 4 to 3 to 2 to 1. Instead of accumulating the values, we'll be multiplying the values together instead. So let's look at it. So we see on top program factorial colon. Then we ask the user to input a value, and we describe that in pseudocode as get the value. Then the total that we're going to send out, whatever the actual factorial answer is, we'll start off by initializing that value to 1. So we do total gets the value 1. Then we're in a while loop, and we're looping around until the value passed in is not equal to 0. So we're going to keep taking 1 away from that value. Keep taking it away each time we go around the loop. And when it gets to 0, we stop. So we don't want to multiply anything by 0, because then the answer will end up as 0. So what we do, each iteration of the loop, we say that total gets the value of value multiplied by total. So let's say we put in the number 3. The first time around the loop, total will be 1, and value will be 3. So we'll multiply 3 by 1, and total will be 3. We'll take 1 away from value, and value will then be 2. So then we'll say total gets the value of 2 multiplied by whatever total is now. the total is 3 now, 3 now, so that means it's 2 multiplied by 3, which is 6. We'll take 1 away from value and it's 1, so we go around the loop again and it's 1 multiplied by 6, which is still 6. We take 1 away and then value is 0, and then it exits the while loop. Then we print out the number 6, so we know that 3 factorial is 6, because 3 by 2 by 1 is 6. If we put in a number like 7, it's the same principle. We start off with total being 1, then it's 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And then we print out whatever that total is. Like a lot of these algorithms, it would be very helpful for me if you guys went and played around with it, put in different values for the variable value, and see how total increments. So work out a few different iterations of this pseudocode and then you'll understand it very clearly. So thanks very much. We'll see you on the next episode.